Thank you all for being here. Good evening. Ramanan Krishnamurthy with UH here. I'm the VP for Energy and Innovation. I want to thank you all for joining us today for this conversation on plastics, chemicals, circularity, what's next. So very quickly, this is me, and if you ever need to send me an email, first name at uh.edu, that works. Anything bad that you don't like about the symposium, anything that you've got challenges with, send me an email. If you like the symposium, thank my wonderful staff who've done all the work that has actually gone into making this a successful program. I want to quickly thank our co-sponsors. This is the Texas Industrial Energy Efficiency Program. This is a part of the State Energy Conservation Office program that's funded by DOE that allows us to put together programs like this and build educational programs on industrial efficiency. Want to have a big thank you to my student volunteers here who come from the Energy Coalition. The Energy Coalition is a very unique U of H entity. Over 5,000 students, 34 different student organizations, engaged, energized, and really cutting edge in terms of the work that they do. I want to thank them for all their efforts to put this together. I want to thank the staff at UH Energy. I want to call out a few people specifically for doing a lot of the work and getting us all to this point. Ryan Harris, Deidre Perry, Tim Henry, Ed Bailey, and Mia Brooks. Without them, we wouldn't be here. And in the back office behind them, Maria Banda, Niurka Tamayo, Sandra Bazan, and Emmanuel Juarez. A big thanks to all of you to getting us here. Unlike most things that we do at the university, this is one place where we're going to actually ask you to take your phone out and do something active with us. And that is really when you want to ask a question, pull out your phone and go to the website, uh.edu/energy/ask. That's the way we're going to get questions from you. You also get that by scanning this QR code and getting to ask the question. Those questions will come in. Our moderator, Tracy Hester, will be the one who will go through those questions and provide them as you give him fodder to really ask questions of the panelists. Want to remind you, please do stay after the event because we're going to have a reception that follows the symposium. Obviously, you've seen the food, you've seen some of the drinks here. Please do stay, get a chance to meet with each other, but also with the panelists that we have. I want to tell you about a couple things that are coming up. One is our program that you see here, that is a hydrogen webinar that we're going to be conducting on September 29th, as well as the program that TEEP is putting together on October 17th that's focused on legislative priorities. Middle October is going to be a busy time for us because we're doing two other things that are going to be big places where we're going to get a lot of people coming together and organizing and doing things. One is Energy Day 2023. That will be at downtown Houston. We expect about 15,000 kids there. If you want to be one of the kids and come and join us, please do. We'll have fantastic exhibits that my faculty colleagues will put together. Please do come there and join us. And the second part of our symposium series is on October 19th. And that is one on the future of mobility, EVs, hydrogen, all of the above. And asking the question, what are the promises? Where are those big, exciting things that are happening? And where are the bottlenecks? And so certainly want you to be there as part of that. With that, I'm going to now introduce a colleague of mine who's got something really exciting for our students. That's Joe Powell. Joe is the founding executive director for our Energy Transition Institute, and he's been here a full solid 9 months now at the university, and he's had huge impact, and he's going to announce something truly exciting.
Well, thank you very much, Ramanan. Now, Ramanan has been here 27 years, and so I'm the new kid on the block and just learning. Retired from Shell, but very excited to be directing the new Energy Transition Institute launched by Shell, and also a full professor of chemical engineering. So look forward to working with you at the University of Houston. And I have a contest to announce, so let's have the contest slide, if we may. But there we go. We've got it circular plastics. So we've got prize money on the table, $13,500 for a Shark Tank-like challenge exercise for you to come up with your idea of a circular economy, how to recycle plastics. So it could be, how do you process it? How do you collect it? What type of products are you going to make? Are you going to make a sweater out of recycled products and sell it? Do you want to go biodegradable and design for biodegradability? Packaging. What are you going to do about the packaging that you get in the mail every day and reduce the amount of that's in the environment? How might you recover it? So what's your idea for picking it out of the ocean and processing it? So those are the 5 areas you can engage in. The contest will have, as I said, $13,500 in prize money. Winning team there will be 5 teams that win money as a result of this concept. So your ideas are due in by the 1st of November. You can work with a faculty mentor. We strongly encourage teams. And then the prize money will be announced at the UH event on November 16th for Energy Night. And so prior to that, we will have a Shark Tank-like judging review of the 5 semifinalist teams, and we will award the money that night. Again, $5,000 to the winners, $3,500 to the runner-ups, $2,500 to 3rd place, $1,500 for 4th, and $1,000 for 5th place. So all you have to do is work with 12 sheets of paper and be creative of how do you want to communicate your idea. You'll be judged on the quality of the idea, how well you communicate it, and then what is the extent of your critical thinking and references that go into it. So 12 pieces of paper, $5,000 on the table. Join up with your teams and go for it. You can find about it on the UH Energy website, or click your phone and do the scan here to get into the contest. Reach out to me, Joe Powell. You can find me on UH Energy as well. Be happy to address any questions. So with that, I'll turn it back to you, Ramadan.
Thanks so much, Joe. So with that, I think we are ready to get launched with our symposium here. All of you, if you've not picked up these brochures, you will get all the information about the speakers there. But I'm going to do the easiest part of this introductory part of the panel, and that is introducing my colleague Tracy Hester, who is a professor of law at the UH Law School here at the UH Law Center. He is a professor of energy and natural resources law, and has been at the university since 2014, I believe. And he has been a collaborator of mine. He and I co-founded the Center for Carbon Management in Energy. I take credit as a co-founder when it was all his brainchild. So he's the person behind our focus on addressing carbon management. And he's been a real asset to the university in terms of what he teaches, but perhaps more importantly, how he goes and brings out thought leadership that the university has in the area of energy, environment, and climate change. With that, Tracy.
And from that, you can tell that Ramadan is an extraordinarily generous soul. Welcome, everyone. Thank you so much for joining us here tonight. Sorry, is that my clicker? Thank you so much. I made the mistake of leaving my speaking notes in the chair when I did realize we were getting ready to start. So my duty tonight is to first welcome all of you here. I must say it's a delight to see such a strong turnout for our first energy seminar this semester. And we deeply appreciate the willingness that you've had to spend some time with us. I actually have got to ask our speaker, our panelists, to come up to the stage, and I'll introduce you as you come up. And I'll make it, and I will try to set the stage a little bit. We are here to discuss the circularity of the economy, but with a particular eye for chemicals and plastics. As we all know, plastics have the virtue that have become, to a certain extent, their challenges. They're durable, they're cheap, they persist, they have an enormous array of different types of uses depending on the flexibility of the products that are made from them. But at the same time, their very durability and inertness has led to a situation where we're starting to also see challenges on how to manage, reuse, and recycle accumulated plastic materials. We're all familiar, for example, with the Pacific Gyre of plastic waste. We're all familiar with the accumulation of plastic materials and recycling needs that we need to address. Simply said, this is one of the foremost issues facing the industry sector. And to give you a sense of the importance and highlights of it, there's 2 different articles that have come out just this week in the mainstream press. One is that Exxon starts up a $2 billion chemical expansion at Texas facility, specifically for polymer modifiers and linear alpha olefins for plastic packaging. So clearly, it is only one of many major investments that are being made by plastic producers because they see this as the future, where they're going to have the most opportunity for growth. Literally, though, at the same time, we have a different article saying that Michael Bloomberg dials up a war on plastics. And he has decided he is going to devote $500 million to fight the construction of new plastics production facilities. So the stage is set. Our speakers today are going to give us an overview on how these dynamics are shaping the industry sector and possible pathways ahead. So in that regard, let me introduce our speakers. Our first is Scott Pasternak. Scott is an Associate Development Manager for the Solid Waste and Resources Recovery Practice at Burns and McDowell that provides consulting services to advance solid and waste and recycling programs for clients. And he's been doing this since the 1990s by focusing to working with clients to solve challenging technical and legal, I'm sorry, I said legal, that's because it's a habit, technical and financial issues. Geographically, he's worked with private companies in 20 different states. And he also did time at the Texas Commission of Environmental Quality, where he was a solid waste planner. Master of Science with honors from the University of Texas. And he's a past director of Swanus Planning and Management Technical Division. He'll be our opening speaker to sort of set the stage and how the recycling secondary markets are stationed in Texas. Our second speaker is going to be Jill Martin. Jill is actually let me make sure I get the title correctly, Senior Fellow for the Packaging and Specialty Plastics business of Dow Chemical Company. She has been there, I have to say, almost for 30 years, but not quite.
You can say that.
Okay, like we almost are going to be celebrating an anniversary during the presentation tonight. She has served in both R&D, research development, as well as technical service and development for the North America Packaging and Specialty Plastics business. She has, in her current role, focused on the development of circular and low-carbon solutions for packaging marketing segments. She has a chemical engineering degree from Carnegie Mellon and a doctorate in polymer engineering from Case Western Reserve University. And then last, to sort of bring all of it together, our speaker is Aura Cuellar. She is the Executive Vice President for Growth and Strategic Projects at LanzaTech. She is at that capacity of identifying new and emerging opportunities for clients worldwide. She's worked at an array of different countries around the world. In her prior role, she was the 24 years at Shell, where she was the Vice President for the energy transition in the United States, where she had a capital projects portfolio of $500 million. Obviously, she's very interested in transforming the culture that drives companies so that they actually are self-motivated and focused on achieving more productive results. But the other thing I have to mention in passing is that she's the honorary counsel to the Kingdom of the Netherlands in Houston. So if any of you have some interest in the Netherlands, side note, my daughter is married a Dutch lawyer and lives in The Hague. She's the one to talk to. So with that, let me go ahead and hand the mic over. I'll make one final comment. You will have an opportunity to have a QR code to post questions. Please save yourselves. I'm a lawyer. My questions tend to have a little bit of a legal spin to them. If you'd like to ask broader questions, we will curate them and make sure that we get addressed during our presentation tonight. So with that, Scott, you have the podium.
Good evening, and thank you so much for having me here to visit with you all this evening. Especially as a fourth generation Houstonian, it's a true honor to have this opportunity to speak with you this evening, and also my honor to have my mother be able to join me here for tonight's presentation. If not for her, I would definitely not be here this evening. It's my one joke, got it out of the way first. So what I want to talk to you about tonight is a couple of important issues. The other panelists, I think, are going to really be able to dive into a lot of the details from a plastics perspective, and I'll get to some of that as well. But before doing that, I wanted to give you some perspective of the work that Burns & McDonnell has done for the state of Texas as part of the Texas Recycling Market Development Plan. It's a very detailed, thorough document for those of you all that are going to take advantage of that opportunity to go after that competition. I think this will be a great resource for you in terms of giving you a really good understanding of what's happening and what opportunities are out there from a recycling perspective here in Texas. And then I want to spend a few minutes just giving you some of our opinions with regard to what we see from a plastics perspective. In terms of Burns & McDonnell, we are a consulting engineering firm. We've been around since 1898. I lead our solid waste and resource recovery group here in Texas. But we do a lot of things across a number of across a number of different industries, including energy. So a lot of the issues that Terry just referenced are ones that we have a very good appreciation of. Let's jump into the Texas Recycling Market Development Plan. So this next slide is the only one that has a significant amount of text on it. So don't worry, all the rest of the slides just have a lot of numbers. But this slide here gives you a sense of the background for the Recycling Market Development Plan. So Burns & McDonnell has now completed 3 different statewide studies on recycling here in Texas, and the most recent one was authorized during the 2019 session of the Texas legislature through a Senate bill that was passed into law. And so that directed the TCEQ to hire a consulting firm, which turned out to be Burns & Mac, to develop this statewide plan. And so it addressed a number of different issues that are identified here on this slide. So I'm not going to go through each one of those in the interest of time, but thank goodness for QR codes, because I will have a QR code about halfway through my presentation that you can scan, and it'll take you right to where this plan is on the TCEQ's website. So if you want to jump in and really understand a lot of those details, that's where you can go. And so all the information that I'm going to be sharing with you that's straight from that plan, you can go right to the website and get all that information. So don't worry about taking any kind of notes in that regard. So one of the things that we looked at for each of the different studies that we've done for the state of Texas is what are the quantities of materials that are recycled from a tonnage and then a recycling rate perspective. So this slide gives you a sense of the total quantities of materials that have been recycled starting in 2015. And so on the left-hand side, it identifies typical recyclables. So that would be just what you would usually throw out as a part of your curbside program. So that includes plastics. There's also organic materials, think of food waste, as well as yard trimmings or brush. And then other materials, of which the most significant from a quantity perspective are construction and material, C&D type materials, so construction and demolition. So in 2015, that was about 9.1 million tons. So fast forward 4 years later, that increased to 12.9 million tons. So think about that, just in the span of 4 years, the state of Texas increased recycling by about 30 to 35%. So just to show you on these next couple of slides a little bit better perspective of how these numbers look from a pie chart perspective. So concrete is really heavy, represents a very significant amount of the quantities of material that are recycled, and so that's shown by the yellow. On the left-hand side, Texas has significant amounts of vegetation, so that's shown on the purple in terms of yard waste. And then you've got everything else just in that kind of upper right quadrant of this pie chart. And so we're going to be talking a little bit about plastics. So the total quantity of plastics that was recycled in 2019 was just under 100,000 tons. And so as important as plastics are from a recycling perspective, and I think they are really critical, from a big picture perspective, there's lots of other materials that also are very important to be recycled as well. This slide just gives you some perspective on what those changes were from 2015 to 2019. Again, all of this data is in the plan itself, but where we saw the most significant growth is right there in the middle between yard trimmings, brush, and green waste. And so, yes, we definitely have done a better job in terms of tracking down all of this information as we go every 4 years to update this survey. But in the case of that material type, there's also been a very significant increase in the number of companies that are in the composting business. And so that's been really, really great to see, and that continues to this day. So one of the ways in which recycling is measured, there are multiple ways, but one of them is a recycling rate. And so the way that you calculate a recycling rate is to look at the total amount of tons that are recycled, and then to divide that by your total tons recycled plus what goes to landfill. So in 2015, it's that 9 million tons, but then we also had about 31 million tons of material going to landfill. So then when you fast forward to 2019, and the recycling tons increased by those almost 4 million tons, when we saw those numbers, we got really excited to think, oh, we're going to have a huge increase in the recycling rate in Texas. And we definitely had a very meaningful increase. However, Texas has an extremely robust economy. And so when you look at the total amount that's being recycled, you now have to divide that by 34 million as a part of that denominator. So there was a nice bump in recycling, but I think we still have lots of opportunity, and I'll show you what I mean by that in just a few minutes. And keep in mind that we did increase recycling in Texas in 4 years by more than 30%. So keep that in mind as I show a slide in just a couple of moments. So one of the key aspects of this plan is to also look at what is the economic contribution of recycling to the state of Texas. And so if anybody is an economics major in the room, you'll love what's in this report because it gets into lots of detail from an econometric modeling perspective. For those of you who are not economists, I'll save you all those details and jump straight to the answer. And so the impact of recycling on the Texas economy is about $4.8 billion in economic impact, and there's more than 22,000 jobs in the recycling industry in Texas. So that all sounds like a lot, and it definitely is, but to put that in perspective, the recycling industry in Texas, from a jobs perspective, is relatively on par with the petroleum refining industry, which is critical to the Houston economy, as well as furniture manufacturing. So a moment ago, I talked about how much Texas was able to increase its recycling from 2015 to 2019. But let's take a look at what the future holds in terms of how much material is still going to landfill that could be recycled. So again, this is all data that's in the plan. And so what this is showing is for those same types of materials, how much of that went into landfills all across the state of Texas. So it was almost 16 million tons. You're probably wondering, how the heck does he know that? We actually do a lot of studies where we get to characterize the waste. So that's sorting trash. It's a lot of fun. But that's data that is real, of there being about 16 million tons of material that could be recycled that is still going to landfill. And so the question that we would pose to everybody across the state of Texas is, what if you could just increase that by 20% or 40%? Then you're talking about increases of 3 to 6 million tons per year. And so you may ask, can we do that? And I say the answer to that is we absolutely can, because we have in the past. Is it easy? Definitely not, but whatever is easy, is definitely may not be worth doing. So there's obviously some key challenges there. So in terms of what I focused on with you all tonight is a lot of the facts and figures from this market development plan, but there's definitely a key strategy component to it, and this is where I would encourage you to, again, here's the QR code, is to scan this, and you can then get into a lot of the details of the plan itself. What we have listed over here on the left-hand side are the table of contents. So again, everything that I've talked with you about tonight is in there, but there's also extensive analysis on a material by material basis in terms of the supply and demand, barriers and opportunities. So again, if you're a student interested in that competition, I bet you can find some good ideas for a potential project there. We won't even ask for any cut of the winnings there. All right, so let's talk about plastics. And so a lot of the work that we do is not only projects like for the state of Texas, but we work for a lot of cities to help them plan for, develop, implement, manage their recycling programs. We also provide some consulting for private companies that want to increase their recycling as well. And I think that plastics are, on one hand, a very important part of what we do from a worldwide perspective. I mean, just think about all the utility that we get and benefits that are out there from a plastics perspective. But then, as Tracy mentioned, they also come under a great deal of scrutiny. So I'm not here to tell you plastics are good or bad, but what I want to emphasize is that there's all sorts of different types of plastics and a variety, and that has a significant impact in terms of how they are managed, say if you are a city. So this slide gives you a sense of what are the types of plastics that we typically see from a city perspective. And so the ones on the left are the ones that citywide recycling programs are designed to take. So when you set out your recycling program materials, your water, soda bottles, detergent bottles, as well as milk jugs, those are all products that the recycling facilities are designed to process those materials and then to sell them to market. But then when you have other materials like rigid plastics, mixed plastics, and then plastic bags, those types of products are just much more challenging to be able to process at a recycling facility. So when I say a recycling facility, what am I talking about? This is just an example of one that Burns & McDonnell designed for a client. It's about a 100,000 square foot facility. So inside it are a significant amount of equipment to process that material. So it'll separate the material through a series of conveyors, optical sorters, other different types of technology into all the different material types. One of these facilities, state of the art today, is about a $60 million investment. And so when you say, well, what can we do to recycle more different types of plastics? When you develop this type of facility and you make that type of capital investment, that becomes a real challenging type of question. And what we think is really important is to think about what are the most important plastics to be recycled, both in terms of the quantity and the value of those materials. And so if we take the main types of plastics that we see recycled at facilities, this is data from another city that we work for, where we actually calculated what percentage of the recycling stream plastics represent, multiplied that out on an annualized basis, and then multiplied that based on what those materials were selling for at the time in terms of the market values. And so you can see that water, soda bottles, milk jugs, detergent bottles are all worth, for this city, tens of thousands of dollars, whereas the mixed plastic is a much lower percentage of the total quantity, and it's a material that's just not worth as much. And so from an economic perspective, it just creates a lot of challenges in terms of what are going to be the best ways to recycle those materials in the future. Now, that does not mean that we shouldn't figure out those ways, and again, bring up this student competition. If you can find a really viable way, what's an effective solution for mixed plastics once you understand their quantities as well as the economics of it, that's where you can start to make some headway. I know we're in Houston, but I wanted to share with you some results from a project that we did for the North Central Texas Council of Governments in the DFW area, where we did extensive characterization work to understand how much of broad materials like paper, plastic, metal, and glass are being recycled, which are the percentages on the left. And then what's on the right is how much of those materials are unfortunately still going to landfill. So if we talk about plastics, only 22% of those plastics are actually being recycled. And then from a financial perspective, this is my last slide, is if you look at that, not just from a tonnage perspective, but from a financial perspective, if we just take PET, which is water and soda bottles, the bottom part of this line, that's the shaded part, that shows how much is going to landfill and what the financial value of that material is. And it's tens of millions of dollars that's being thrown away, literally, into landfills each year. And so that's what I would leave you with, is that so much of recycling, just comes down to basic decision making in terms of, if you've got a water bottle, what are you going to do with it? Is it going to go in the trash, or are you going to make sure that does get recycled? All right. So here's my contact information, and I will now turn things back over to Tracy.
Just a reminder to everybody that we do have the QR code set up to curate your questions. So we very much want you to actively participate in this discussion. Please, if you can, put them up during the presentations or immediately afterwards during our moderated discussion. Our next speaker is Jill Martin, and she's going to provide the perspective of an international commodity plastics producer and the work they do in the circular materials space.
Couldn't see anything while I was sitting up there, so I'm going to stand over here so I can see what I'm supposed to be talking about. You just have to look this way. I might wander over there. It's the nature of the beast when you give the third presentation in a week that you really are thinking to yourself, what did I say the last time I talked? So a little bit of background that Tracy didn't give you about me is I think I was intended, or I always was destined, I think is a better way, to be in the recycling space when I was a teenager, and it was a while ago. I lived in a town outside of Cleveland, Ohio. It's up in the north, where the weather is much more pleasant than it is here right now. And I got some sort of strange inkling that maybe we should include or improve the recycling in the city that I lived in. So I worked with the community there. That was the first time I ever encountered city government. And figured out a way to actually bring some better recycling systems to a very small town outside of a major metropolis. So fast forward about 6 or 7 years, now I'm in grad school and I'm still in Cleveland. And the first project that I worked on is actually from BP, British Petroleum. At the time, they were manufacturing a lot of plastics. And so my master's thesis was basically, how do you make high-density polyethylene and linear low-density and low-density polyethylene work well together in a recycling stream? So again, working on these problems way before I actually spent almost 30 years at them. And I'm now back in recycling, and I have to tell you, it's one of the best jobs I've ever had. And I say this to everybody that asks me about what I do, because not only do I get to still work on the material science of plastics, but I do get to work with a multiplicity of people that I never anticipated working with, and that means waste haulers. It means people like Scott who are collecting all sorts of data. It means entrepreneurs who are interested in figuring out a way to get to, again, low carbon and circular solutions for plastic waste. It means I work a lot with our government affairs team to try and understand what does policy actually mean when you're talking about managing materials. And of course I get to work with a phenomenal R&D group, not only at Dow, but also with many of our external partners. So again, I'm living my best life. I don't know what I'm going to do when I retire, but my friend over here told me that he's sort of retired, but he's still consulting. So I know there's life after Dow. All right, so with that, I'm going to actually share with you perspective, again, mostly focused on plastic waste. I'll give you more stats, but I'm not going to give you as many stats as Scott just gave you. He is the master of data, so I won't even attempt to go there. I'll talk more about it in terms of the approach that we're taking from a company perspective. And that means, what do we have as far as a goal is concerned? how do we think about the best types of systems out there? What are the right technologies moving forward? And I'll answer that question right now by saying there's a multiplicity, and it depends on what you actually are doing in what region. And then I'll finish by, again, challenging this group as a whole to what are some of the more interesting science-based problems that we have in front of us. How do we use new tools that are becoming more and more important for the recycling industry and for waste as a whole. Okay, so with that, and I told Ramanan that I was repeating a couple of slides that I had given earlier this week at a symposium that AICHE put together in West Houston. And really, again, looking at the intersection, and I say intersection, yet what I really mean is that all of these are obviously very intimately related. When we talk about waste, of course, it's a diversity of materials. Of course, the end of life of those materials is going to depend on the value of that material once you've recovered it, and of course efficiently recycled it and put it back into the market. So what must be true is that yes, you have to get it back, but you also have to have a process by which you can convert that material into something new. Whether it's a jacket, or it's a shovel, or it's yard trimmings, you really need to have a process and market for that to make it, again, whole from a circular economy perspective. We also think about carbon in the context of how much are we emitting through the processes that we use, not only to drive to work every day, but to manufacture polyethylene pellets, whether we're manufacturing those in Freeport or we're manufacturing those in Terneuzen, which is in the Netherlands, which I had to say. The other part of it too is that you'll notice, not surprisingly, and this was one of those moments when I was making this slide where I thought, well, this sounds like the dumbest slide I've ever put together in my life, but I thought it was interesting nevertheless, that of course waste, carbon, and circular solutions are extremely diverse. So there's no one answer. And putting together what the right combination of those, again, depends on multiple factors, and Scott talked about those a little bit as well. So again, the goal here is ultimately, obviously, to make sure that we're reducing waste and carbon, but also increasing the amount of money that we make out of circular systems going forward. So I'm going to give you a little bit of insight into the waste management in the chemical industry. Scott talked more broadly about what that looks like when you think about the consumer waste that we're talking about. Now if we look at, again, manufacturing operations, these are some data that came from, again, the EPA, which is the master of data related to waste, in case you were wondering. And they break it down in terms of, again, not only what you're doing with the chemicals from an end-of-life perspective, but they also look at the value add. And again, this is an extremely important part of the waste management industry. I think most people look at waste and they think it doesn't have any value. But if you think about the valuation for a number of the waste haulers, and again, those are waste haulers across all commodities, it's quite significant. It's certainly the size of a major chemical company, upwards of $50 billion. So this is not an insignificant industry. These companies are not small, and their diversity in terms of how they're approaching these problems is obviously very broad as well. So again, this is again from a chemicals perspective. The same data are available if you look at it from a plastics on-site. So again, if you were to come into Dow ever and talk to somebody that manages the waste, they would talk about all these different things that we're doing in order to, again, avoid any type of landfilling and avoid anything that is going to prevent us from being able to reuse those materials going forward. So the second thing I want to talk about is just a little bit of reiteration of some of the data that Scott had presented, but again, this is looking more at the ACC report that came out about 3 or 4 years ago on the roadmap to reuse, and again, very focused on plastics, but looks at, again, data as far as what is going into the waste streams today. And what I really want to focus on is actually not those data, because again, you've seen them already in much more detail, but to really look at what we call the actions for mitigation. And these were proposed by ACC, and I've done my best to really take this into a material neutral space. So that even though I work in the plastics industry, certainly when we're thinking about what are solutions to manage waste, these 6 truths must to a certain extent be acknowledged. The first, of course, is that you have to engage your value chains. So again, who were the economists in the room? How many economists in the room? Pick one. Right, okay. Value chains. Value chains, super important to manage the flow of material and of course to maintain the margins along the way. Nobody does anything without making money. Well, okay, most people don't do that. Most people want to make some money. But again, the importance of the value chain is that you leave it whole. So if I were to go around the next person in the value chain and try to work with somebody else to sell my product, it most likely would not leave that person in a good position. They'd lose money. So what we've discovered is that when we're talking about waste, we actually really need to go in the other direction. And actually, I'll call the other direction, but keep going around the circle. So talking to people that were hauling waste was extremely important, extremely eye-opening in terms of what they had to do every day. Scott made some comment about, sorting waste is so much fun. I've done it. I've sorted a bale of plastic waste, and there's no fun. There's no fun in that. I don't know what he was talking about, but it was not fun. There's also the element of consumer education and engagement. Every single project that we are looking at relies on us to make sure that if we're going to ask the consumer to do something, that it's very straightforward. And it doesn't interrupt the general flow of their lives on a day-to-day perspective. And again, at the end of the day, there's some value returned to the consumer as well. It's important to also have access to recovery and recycling facilities. One of the, again, reports, and I don't think it's in the ACC report, but it's in the Recycling Partnership report, is that the access for rural communities to recycling is extremely low. Volume of material there is also very low, but if we're thinking about tapping into waste streams on a broad basis, we have to acknowledge that the way we get those materials to hubs where they can be processed and sold back into the market is going to require us to put some carbon back into the system. So thinking about local management of waste and what those processes look like need to be on the table as well. So the other part of it too, and the last 2 points here, are really the build out of technologies, and I'll talk about that a little bit again, very much in the broad spectrum of recycling technologies. I'm not going to say that reuse is not important. It's absolutely important where it can be instituted, but certainly my focus is going to be on the recycling of materials, because at the end of the day, that's part of what we're trying to drive for here from a circularity perspective. The very last thing I'll again reiterate, because I do think this is a surprise to a lot of people, is that when we talk about recycling, we're really talking about there's an end market for those materials. And the end markets that we all know about today, flower pots, park benches, those are insufficient if we're really going to hit recycling rates that matter. So this is, again, a little bit about Dow and our Transform the Waste goal. So I'll mainly say that what we had originally put out in June of 2020 was that we were going to, again, collect and find a home for 1 million metric tons per year. Again, based on circular solutions and renewable solutions as well, and that's a fairly new word, and I'll talk about that in a little bit. But we upped the ante on that last year because a lot of people came and said, 1 million, how about if you take that up a little bit? Again, we produce probably about 3 times that amount of material, so putting this target in front of us has been something that I think is well received by the industry, but it's also been a challenge for us as a whole to figure out where are those materials coming from. Again, expands where we were before, but it also is enabled by a lot of the recycling partnerships that we've announced, both in the area of mechanical recycling as well as in the area of what I call advanced recycling. Again, we need to make sure that when we're talking about how we're going to transform those ecosystems, we need to figure out how to scale the technologies. And the business models that we use today as a chemical and plastics industry are probably going to be changed drastically in order to make sure we have access both to the raw materials as well as to those end markets going forward. All right, so these are the 3 challenges I usually work around, and I've mentioned them already a couple of times. Number 1 is that, again, if we're talking about 3 million tons, we cannot be using the same materials that we've been talking about. Scott was talking about PET and high density polyethylene, so we don't make PET, we make a lot of high density, we make a lot of linear low density and low density polyethylene to go into those films. We want those films back. And so we're gonna talk a little bit about one of the programs that we've been working on for the past about 6 or 7 months and the key learnings from that program. Really to think about how we're going to get those materials back so that people want to buy them and use them in new articles. This is really utilizing our expertise in terms of material science. I mentioned before that, again, when we're thinking about these materials, we're thinking about fundamentally their carbon and hydrogen for the most part in the polyethylene space. And so if we treat these materials from a fundamental perspective, it means we need to measure from a fundamental perspective as well. So developing the right characterization technology and of course looking at the processes at scale and scale that's relevant for the region are extremely challenging for us. But again, that's how you get to the 3 million tons, is to change a little bit of what you are doing from a scale perspective, but still adhere to the fundamentals around material science. Waste is not as well characterized as we might like it to be. When I think about waste, again, I think about the fact that if you look at any bale of plastic film that's collected today, and if you're, please tell me that you're all putting your films in the storefront drop-off systems. Nodding, everybody saying, I know what she's talking about, and I do that, excellent, thank you. Because what happens is we end up with a plethora of materials. Again, mostly linear low density and low density polyethylene. But I told you I started back when I was a little bit younger in the space of trying to figure out how to blend those materials together again. They're very broad in composition, they might have different additives in them, and all of that factors into their reusability. So the characterization of those materials, understanding that distribution, being able to figure out the end markets with a waste stream that we haven't encountered before is a fantastic challenge, and I'll talk a little bit about some of the things that we might employ in order to solve that challenge. So I'm gonna get right to that, because I told Ramadan I would not give all 33 slides that I gave on Tuesday night. And I'm really gonna focus on something that maybe most of you are working on today, which is artificial intelligence. Specifically in the space of machine learning, we've seen a lot of companies start to invest in machine learning technologies in order to sort plastic waste better. Typically this is done, as Scott mentioned, using near infrared or optical sorters. There's also a lot of manual labor involved, especially outside of the US. So what's the next generation of technology? The next generation of technology is a combination of machine learning and robots. These are already instituted in probably at least 200 or 300 different MRFs today. It optimizes the bale quality, which is what I talked to you about before. We need to have better bale quality so we have more consistency in the material. It also makes sure that you get the paper away from the plastic. You get the high density away from the PET. You get the PVC away from everything else. All of these things are extremely important to, again, realize the right value for that particular resin. Now, again, I'm not sure how fast we're going to be able to identify these materials because most of these MRFs are going to run at 15,000 tons a day. So you need to make sure that whatever you're doing to detect the materials and record the data, you can use it effectively as a feedback loop. So there's actually a lot of fundamental research going into that, as well as I mentioned before, startup companies looking at that opportunity. The other area where we still see some opportunities for, again, I'll call it both collaboration as well as some new methodologies is in the area of life cycle assessment. When we talk about decarbonization, obviously we want to make sure that we're measuring this accurately and we're measuring it consistently across the industry. It's entirely possible that some people might follow ISO standards. Other people may be less familiar with ISO standards. If we're all on the same page about what those standards need to look like and how we use those standards appropriately, how we make sure we have third-party certification of the data as we look at those new pyrolysis processes, new gasification processes, or even instituting maybe cleaning systems and mechanical recycling. All of those particular unit operations need to be taken into account and standardized in the same way, so that when we're comparing carbon, we're doing it on the same basis. Last thing I'll talk about is that there certainly is still on the table the route to new polymer synthesis pathways. We have actually a couple of projects that we're working on with some universities in the area to think about how do we recover materials more efficiently, what are the right catalytic routes to do that, what are the new polymers we need to design to optimize design for recyclability. Again, thinking about the challenges that we're facing around scaling a lot of these processes. One of the things that we certainly started to think even more about is how do we scale locally? How do we not think about a 1,000 kiloton size plant, but how do we think about a 50 kiloton size plant? So that all figures into, again, the optimization. And the last thing I'm saying, primarily because Tracy is sitting here, is the importance of public policy. He's gonna ask us about that later, and we're all going to look at him for the answer, by the way. So make sure you put that in there and specifically ask Tracy to answer the question. So it's going to be critical though, because again, as I mentioned when we're talking about LCA, is consistency in terms of the way we look at the data, consistency in the way we look at materials. So material neutrality is extremely important in policy so that we're not saying plastics are bad, paper is good, metal is okay, again, glass is okay. We want to make sure that all of the ways we measure and apply policy are consistent across materials so that we're choosing the right materials to use, whether we're talking about packaging or we're talking about pipe. So I'm going to stop there and thank you again for your attention and look forward to the discussion.
All right, and yes, first, congratulations to Jill for putting me squarely in front of the train for the Q&A session. And second, I want to remind you yet one more time that if you would please scan the Q&A, scan the QR code or put your questions up. so we can curate and make sure that we have a great and vigorous Q&A session after we get done the presentation. It's now my pleasure to introduce, to bring up our third final speaker, Olive. She is going to discuss the view of a national player on how new products are defining material circularity.
Good evening. Thank you, sir. So before I start, a couple things. I was reflecting on the title of this session, Plastic Chemical Circularity, What's Next? I think I'm on the what's next category. I'm going to talk about carbon recycling, but specifically taking from gases and making ethanol and the products that we use in everyday lives. But before I do that, first of all, is this working? Oh, there we go. Sorry. I feel compelled to talk about a couple of things as part of my introduction. So first of all, yes, I am the consul of the Netherlands, and I'm very honored to do that. But it's very important for me that you know that I'm a very proud Colombian citizen. I don't know if this is working well. Yeah, okay. I am a very proud Latin woman, and that matters to me. So 3 things I want to share. One is that's a very important detail. Second is I have 2 young children. And when people ask me, why did you move from a major company to a startup company after almost 25 years in it, and what are you doing? I often, the choices that I make, especially as a mother, are related to them. When I think about my children, I think about how old they're going to be in 2050. They think they're going to be old. They're going to be in their late 30s, 40s maybe. And I firmly want to make sure I do my part so that when they are in their 40s, they have a life at least as good as the ones we have. And for me, that centers in 2 pieces. One is addressing decarbonization of the world, but also specifically addressing economic development as well. So profitable decarbonization is something that I'm extremely passionate about, and it's one of the main reasons why I joined Lancetech. So Lancetech, I actually don't love to use the slides in general, but I have learned in Lancetech, many people might think that we're talking about science fiction, so I'm going to tell a story using pictures. I still feel the mic is not fully working, so if it doesn't work, let me know, because I hear different things. So, buddy in the back, confident you to let me know. Got it. So I want to tell a story on pictures, and let me start with Lancetech. So Lancetech is a young company compared to others that have been in the world for 100 years plus. Lancetech is started as a biotech company, and it's been operating for about 18 years. The company focuses on recycling of carbon to make the products that we make, that we use every day. So let's look at what the product is. So anybody here likes beer? Anybody here knows how to make beer? Well, a couple of people. I actually did not know how to make beer, apart from I knew just some yeast and some stuff. Well, gas fermentation is the heart of the Lancetech process. What it does, it takes gases, many different types of gases, industrial gases, waste gases, and is able, through a gas fermentation process, be able to make ethanol and be able to make the different products. So our gases can come from industrial waste, our gases can come from agricultural or just municipal waste, as we've been talking. In that case, you need to go through a gasification process. And of course, electrolysis and when direct air capture is ready to be working at a scale, you can certainly take gases from that source. After the Lancetech product process is finalized, we make fuels, so ethanol that can go into the ethanol market, but it can also be the feed product for sustainable aviation fuel, or it can go into chemicals, such as clothing, soaps, perfumes. So you may ask, well, that sounds pretty fancy, is it real? So it's important to know that this is not science fiction. I meant to add, it's all about a recycling economy. So this is where I just want to show you what it looks like. So I joined a startup company, but a startup company that is already commercial. So as I shared, the company is 18 years exactly. In 2005, the company was already working on laboratory experiments of what does gas fermentation look like for gases that you can take and make ethanol and then make products. By 2008, we had pilot products, and 2012, we had demonstrations. Up to at that time, we had over 200,000 tons of CO2 avoided. But since then, we now have, by the end of this year, 6 plants that are commercial. So I want to show you a couple of pictures so you see what they look like. It is not science fiction, it is real. So this is the first plant built in China. Important to note, 46 KT for those chemical engineers in the room, and for those who know plants, it is a significant amount of product that is made. In this case, the emissions come from a steel mill plant. The next plant in operations was also in China. In this case, it was ferroalloy gases, also that are processed, 46 KT. Larger plant thus far, also in China, ferroalloy emissions in operations 2022. And this one is one of my favorites. This is a plant that is actually in commissioning right now. This is in India, and it is the first time that the feed to the plant is CO2 as a feedstock. So in India, what we have is CO2 with hydrogen for the country that is taking those gases, and instead of emitting them, they are taken through the LanzaTech technology. The LanzaTech technology abates the carbon. So the carbon reduction, it takes the CO2 and is able to reduce the CO2 and convert it into a product. This one is one project that I'm personally connected with. In fact, I'll be there on Monday. And this is in Belgium. It's a big deal because in the Western world, unfortunately, I have to say, sometimes we look at what is happening in the East, whether it's China, India, or other places, and says, no, I'm sorry, it cannot work in the United States, it cannot work in Europe. So it is a big deal that we have the first plant currently in a startup mode in Belgium. Couple of things to know about this picture. So it's Belgium, it's next to the ArcelorMittal plant, so you can look in the web and you can see all the information. This is public information. The project was partly funded by the European Union. The capacity is 64 KT. It is a real plant, as if you were walking into a refinery or a chemical plant that is operational. Really important, each of these products, especially the latest ones, the intent is to abate carbon, but be able to have profit, be able to buy, especially in Europe, by having this plant, the ArcelorMittal team can continue to produce steel in Europe because they are abating the carbon, they're not having to pay the carbon taxes, but they're now making a product that can be sold to continue the carbon recycling economy. Okay, I do know we have a couple of chemical engineers, so again, this is not rocket science, and I promise I'm only going to cover the first equation. But people ask, so how does it work? How does the bacteria work? Accenture is a biotech company, so we, LanzaTech, I now say we, I have been with the company a short time, but LanzaTech has been able to work with a bacteria and modify it so that it can take the CO, let's just look at industrial gases, the CO and the hydrogen, and the energy and the gas to be able to make ethanol. Depending on the amount of hydrogen that you have, it is relevant to the amount of carbon that you can abate. So the more hydrogen you can get to a space where you have 100% abatement. I'll leave it there because I recognize that everybody's a chemical engineer. So what does this mean? What happens when you abate the carbon, so less CO2, that is good for the environment, good for addressing climate change, but what happens with the product? And this is the recycling story. So ethanol, as a starting point for multiple products. So ethanol can be converted and upgraded to ethylene. Ethanol can then go into olefins and paraffins and be able to be a feed for sustainable aviation fuel, as an example. Here's a good, on my right-hand side, you see the LanzaTech product. On the left side, you see LanzaJet. LanzaJet is actually a company that has been a spin-off from LanzaTech because this LanzaJet has now really focused on taking the technology, gas fermentation technology, further and be able to just focus on production of sustainable aviation fuels. back to ethanol, you can also go directly into many different chemicals, polyethylenes, MEG, PET, many more. So really a building block for being a full carbon recycling. And if you think about it, and I will venture to show you the box actually in a minute, it is incredible to think of having gases, pollution, being able to be captured, use a bacteria, gas fermentation, and be able to make chemicals that allow you to make products that we use every day. So let's take a view of a couple of products. A key piece of LanzaTech is not just to make the ethanol, but it's working fully with it for the full recycling economy. So LanzaTech works directly with different brands, which today, if you go to their website, you can buy the products. So for example, Coty is the main brand for the Gucci perfumes. And today, you can go and buy a Gucci perfume where the liquid itself is 100% recyclable carbon. Zara dresses, you can buy as well. The On shoes, which are now quite fashionable if you know them, the sole, some of the sole of those tennis shoes are made with recycled carbon. Unilever soaps as well, being supported. So LanzaTech is about taking time to rethink carbon and using biology and engineering and that marriage on how can you convert and create different chemicals, such as right now when we have commercial is ethanol, but the company is working and has over 1,000 patents already for making many more chemicals, including acetone, isopropanol. Those other chemicals are not commercial yet, they're different stages of development. And you can think, actually, there is over 100 chemicals that the company is working on to produce. The idea is that the plants that I showed you earlier, not the ones that are science fiction, you are able to put in the bacteria. The bacteria is just like yeast. It is anaerobic, and it is fully certified in the EU, in the US, in pretty much every country at this point, and is able, like a living organism, be able to come and, if you may, munch on the gases and be able to transform the composition to make different chemicals. The idea is that in the same kit with the same plant, you can potentially put in different types of microbes so that you have the same reactor, the same feedstock, the same process, but depending on what chemical you want to use, you might use a different microbe. It's about a circular carbon economy. It's about making sure we support further feed for sustainable aviation fuel, further productions of chemicals that make the products that we need every day. LanzaTech, as I shared, the feedstock is gases. It is point source, which is actually, that's a picture of the steel mill, like the ones I'm working with personally. But again, it can be agricultural, it can be municipal waste. And when direct air capture is ready, that will be the case as well. And as I said, to make everything we need, a way to think about LanzaTech and the technology is rethinking refinery. It's thinking how you take on the pollutions that we get from many of the plants that make products that are essential for the development and economic development, but be able to think about it and take them into a full recycle process. Certainly, having clean energy is a key factor. Marrying biology, engineering to make all the products that we need to live our daily lives. So with that, I thank you for your time. I look forward to your questions.
For everyone, you may have noticed our presentations were spectacular. So as a result, we've used a little bit more time for the presentations, and our questions as a result may be a little bit more truncated. So what I'd like to do is offer up a couple of questions for the panel for moderate discussion, and then turn to your questions and make sure we save enough time for brief closing statements from each of our panelists. So I think the first is, Jill quite rightly pointed out that I tend to ask public policy kinds of questions. So I've taken the question and perhaps twerked it a little bit. I was going to ask all our panelists, if you had a wish list, it's obvious that the challenges facing the circular economy and reuse of these materials they're not small. And we need to find the best way to sort of get those opportunities available to people. If you could go to, say, the federal government or any other particular institution and simply say, there's one very important thing, that breakthrough thing you really want to have support on, the thing that's holding us back, what would you say is the thing that we need to be focusing on? Oh, you each have to ask.
Mm-hmm. So I'm going to keep it really simple, but based on what I shared in my presentation, I think it would have a very, very meaningful impact, and that is, how can all of us in this room and across the country and across the world just do something so simple as to recycle things the right way? To be able to know what to put in what bin. And that sounds so simplistic, but in reality it proves to be amazingly difficult. So that's what would be that was the first thing that popped into my mind.
Joe?
I think as a process person, and I look at the opportunities that we have for the acceptance of technologies, we're running into a lot of concerns around the consideration of chemical or advanced recycling as a manufacturing process. And it is pretty important to consider it that way, because there's a different way that, of course, policy and regulations come into play when you're talking about a manufacturing process versus a waste treatment facility. So our number one priority is to really make sure that as we're thinking about what the right processes are, that it's expansive in terms of the consideration. It doesn't mean that we are going to ignore the impact from an environmental perspective, neither from a community nor from a carbon perspective. It means if we don't allow for the innovation, then most likely we won't be able to achieve the decarb and circularity goals we have.
Can I give two?
Go for it.
I would say the first one will be carbon pricing. I think thinking about carbon pricing, not just for the country here in the US, but really thinking globally and be able to enable a global economy that takes into account the price of carbon, the real price of carbon. But the second one, now working for a biotech energy company, is being agnostic to technology. Here specifically in the United States, policy is really shaped for many reasons through history with advantage to certain technologies. So in the case that we saw from all of us, different gases, as an example, are covered differently by policy, and therefore enabling or holding back deployment of many different clean techs.
Excellent. And actually, I now have a question from the audience, which I think is directed to you, Ara, but it could also maybe include some commentary from our other panels as well, about the use of captured CO2 from the facilities to produce aviation fuel, sustainable aviation fuel. Doesn't that end up resulting in basically re-releasing carbon back into the atmosphere, or does it result in a plus or minus in the long run?
Yeah, I would say worldwide it depends, right? It depends on the sources. I'm actually right now really focusing in our projects in Europe. In Europe, there is a very stringent regulation of what allows you to qualify for a fuel that can be used for SAF. So I would say there is a lot of development of regulation depending on policy, depending on where you are. It is very important to look at that and make sure that you don't start with good intentions but do not have the right result. The utilization of clean power, and quite frankly, really looking at the full supply chain that feeds the economic analysis, the life cycle analysis of that process is what determines, depending on the region, that's highly regulated.
Y'all have any perspective on that?
I'm going to give it a shot
Okay.
because I know very little about SAF. But again, I think you referenced it already. Because if you're basically taking a feedstock that would be otherwise waste, you've done sort of your job at some part of the process because you've decarbonized because you haven't used new material to make it. I agree that, of course, the back end is always challenging because we haven't necessarily figured out how to, again, capture the emissions from the aviation industry. So that still is a challenge in front of us. But I think we need to look at where we're going to be capturing carbon And it could be that we are capturing carbon in these processes, as Ora talked about, but it could also mean that there are some interesting opportunities for us to think how we capture them in other ways. We won't be perfect, but we will strive for it.
All right, then one other question, and this one I have to confess is a bit policy-oriented, but I just can't resist. I was wondering to what extent environmental justice and environmental equity concerns have started to surface in some of the discussions about the circular economy. And it's clearly been a bit of a flashpoint for siting of new plastic production facilities, but I would assume that you might be dealing with some of the same constituencies for reuse as well. Mm-hmm. And that's what any of the three.
Yeah, I can start off from an environmental justice perspective. So just last week, the EPA awarded about $100 million in grants to communities across the country. And one of the very important criteria as a part of their selection basis addressed environmental justice. And so I think that was really important. We were fortunate to advise a couple of our clients in helping them to develop those grant applications, and so to have that opportunity to work directly with those municipalities to really help them evaluate what would be the best opportunities to have those grant dollars be really effective and purposeful from an environmental justice perspective was quite frankly pretty new. So that was something that EPA had previously not done. And so I think that's just one example of what's happening from an environmental justice perspective. And EPA does have a great tool called their EJ, so Environmental Justice Screening Tool, that can provide all sorts of great information about communities from an environmental justice perspective. I know we utilize that even just to really understand key aspects so that when we're helping our clients to design their recycling programs, it provides key information in terms of how to target campaigns, what types of educational levels you're dealing with, so that you can then draft information so that you target your audiences in an effective way. So I think there's going to be a lot of effective progress based on what we're seeing from an environmental justice perspective.
I can add a couple thoughts. So certainly from the EJ, environmental justice and from policy, but let me answer the question from a technology perspective. One of the elements that is really important for LanzaTech is to think about how can the technology be deployed, continue to be deployed at a scale, perhaps redefining the traditional thinking of having the major centers of energy production. Because if you looked at those pictures of waste, especially in countries where you simply have disposal of waste and they are burned, they're not often seated right next to both the major industrial areas. So being able to develop technology that can be deployed to all different types of community, yes, right next to the major manufacturing, but also in the cities that do not have any industry that right now just take their garbage and burn it, is an essential strategic element to take into account that is addressing environmental justice at a different level.
Yeah, maybe just one final comment to build off of that is, again, it's interesting kind of the balance is necessary because a lot of manufacturing does benefit the community from a jobs perspective, but I think your point about putting manufacturing where, again, it's tied to the communities in a way that, again, is positive from an EJ perspective is, I think, going to be a challenge. I don't know that there's necessarily one way to figure out where to put something, but you want to make sure that the community benefits first and foremost from an economic perspective, and that means jobs, but it doesn't mean that you have license. So I think that will continue to be something that drives not only the EPA, but the government investment as a whole.
And I'll offer a moderator's postscript, which is that we're already seeing environmental justice issues shaping the ability to site carbon sequestration facilities and carbon injection wells. I suspect a lot of those dynamics we're seeing developing along environmental justice lines they'll naturally resurface as well when we talk about circularity and recycling of other types of plastics. So it's going to be perhaps useful to look at the tool set that has been developed to deal with those kinds of issues, such as community benefit agreements, such as expanded consultation and stakeholder negotiations, such as explicitly deciding and identifying where the environmental justice issues are as an early step so you can forestall some of these issues, because they can be a showstopper. But I think at the same time, we're going to have to make sure we address them explicitly and proactively if we're going to be able to support and incentivize the creation of these types of facilities. Now, having said that, as always when you're having fun, time just flies by. So, believe it or not, we're getting near the end of our time. I want to make sure we have some opportunity for each of our speakers to have 3 to 5 minutes to offer some final closing thoughts, and then I believe that Rahman will have some final remarks for us to wrap things up.
I have ladies go first this time.
I'm going to start this end.
So I really wanted to say at the beginning, it's really a pleasure and honor to be here with you. I have, for different reasons, engaged with U of H throughout my career. And I think that when you are looking at changing and shaping the future of the world, the economy, the policy, it happens in places like this. So what I would say is, as you look, and I think it's a fantastic panel that we have together, because we represent such diverse elements of what it takes for a circular economy to become real and to really and to impact the world. I would say, it's really essential to follow your passion, but think through it in a global way that is really touching the community, as we spoke in IAJ and the EJ, excuse me. That is touching the economic development, that is touching the research that so many here do at U of H, that is allow us for the work to continue to progress. I bring it home to Houston. Houston, as many would like to say, is the energy capital of the world, and the people in the capital of the world, of the energy capital of the world, are here. So I would just like to wrap up saying, I think that the diversity and the importance of what we're talking here is at the heart of the future. And it's really a pleasure to be here.
I guess I'll have to tell another story. So about 5 or 6 years ago, I was actually in Austria visiting a couple of recycling manufacturers, and I also had the opportunity to visit the University of Leuven, which is a very well-known university for plastics engineering. And the professors said to us, we were having a really hard time getting students. And this was at the beginning of, or probably in the middle of, a lot of legislation that was anti-plastic and trying to figure out a way to basically regulate it out of the economy. And so the parents were telling their children not to invest in that as a career. And I was shocked by that. And I said, why would you turn away from one of the most exciting challenges you have as a scientist and engineer? Why would you turn away? You have the opportunity to have a tremendous impact on the world that you live in, and you're turning away from that opportunity because you're afraid that somebody might tell you that plastics are the wrong material. You will have the data, you will be doing the science, you will be talking to people. This is your opportunity in the plastic space. And that's what I told people 4 years ago when I was here, and I think it's true even more so now. This is a very exciting time to be in the space of looking at waste and recycling and plastics and materials as a whole. And I know that not everybody here is starting a career. I know some of us are thinking about what our next career is, but I would urge you to think about how you get involved in basically this type of work. And thank you again for the opportunity to be here.
Yeah, I think, Jill, what you just said is a great perspective, and I would urge you to, whatever the issue is that you're really passionate about, is to really take a deeper dive into taking the time to research what's really going on, and I think plastics are a great example of that. I think that there's a bit of a litmus test that gets passed around with regard to plastics, where they get labeled as this, that, or the other. But I think to really just fully appreciate what is the value that plastics bring to our community and for the lives that we enjoy. But then also to recognize that there are a number of challenges. So again, that doesn't mean that plastics are good or bad, but as Jill said, I would really challenge each of you all who are students here is to embrace that challenge and to figure out what do we do going forward. Whether it's how to make plastics that are easier to recycle from a circularity perspective, or for those that are already out there to also look at how can they be more
easily recycled, and just getting back to a lot of those basics to make recycling very successful.
Thank you. All right, and I will ask you at the end as well to have yet another round of applause for our fantastic speakers. But let's do it now. I'll offer a final comment as moderator. First, I'm going to break my heart. How many lawyers are in the room tonight?
There you go.
Awesome, my tribe is here. I just wanted to urge everybody to watch this space. There's a lot of activity going on that will drive some of the technological innovation, and it's happening right now. Negotiations in Nairobi are continuing for the UN Plastics Treaty that is going to be potentially setting the framework for some of these issues. California has passed some interesting new legislation as well that may spur a lot of recycling initiatives. And a lot of people are thinking about how to transfer all the experience we have with renewable energy and credits for the sales of those to essentially renewable values of recycling. Picture RINs for plastic. So with that in mind, I would just like to say thank you so much for joining us tonight, and I would like to pass the mic on to Dr. Christian.
Thanks, Tracy. Thanks to the panelists, Scott, Jill, Aura. Thank you so much for this wonderful conversation. I think this was great. There were a lot of questions. I think there were over 40, 45 questions there. So we didn't get to see all of the variety of questions. But
thank you for that.
You're all here. The panelists will be here for a few more minutes at least. So please do get to them and ask your questions. That is one of the best things that we do at this symposium. I want to remind you a couple things about a couple different symposia that are upcoming, and I hope those slides are here. Want to remind you about, first of all, the upcoming event. So we've got the next one on the future of mobility. Please be here on October 19th. That will be a really fun event. Please come to that. We probably will try and get a ride and drive with EVs. So if you want to come and drive a new EV, we'll probably have something there. Again, remind you about what Joe mentioned to all the students here. That circular plastics competition is live. It's available now. There's $13,500 at stake there. So with that, I want to finally come back and thank our four panel members. Tracy, thank you so much. We'll give you a little bit thank you note there. Scott.
Thank you very much.
Yeah. And there's gift bags right behind you, so which I didn't go through the pain of pulling out and giving you, but that's what is behind there. So thank you so much, and again, please do stay. There's some food and some drink left, more drink than food, but hey, that's part of our life here. So thank you so much.